Hi, everybody. My name is Mark Rocha. I'm a structural engineer at HDR, and today I'll be talking about structural engineering workflows for interoperability and lifecycle analysis. Just a little bit about me. I'm a structural digital practice lead at HDR. I've been with the company about 10 years, and this is my first time speaking at AU. A little bit about HDR. We're about a 10,000 plus firm. We have about 210 offices all over the globe, and we specialize with everything between engineering, architecture, and construction services. A lot of my focus is with parametric design, workflows, and all sorts of analysis with that. Just some of our learning objectives today. The first one, we just want to do an overview of all the current tools available when we go from interoperability between structural analysis and BIM. Secondly, we want to talk about BHoM, which stands for Building and Habitats Object Model. We want to go through the installation of BHoM and intro to a lot of the BHoM adapters. Third, we want to get into using Dynamo to generate a robot analysis model and a Revit model. So we're going to show several different workflows that you can use. Fourth, we're going to get started with life cycle analysis using BHoM to evaluate embodied carbon. Just starting with why, taking a page from Simon Sinek. This was one of the first projects that I worked on, and as you can imagine, it's a big old spreadsheet, and so there's all sorts of things in it. And I remember going through this iterations time and time and time again, and it was very frustrating because as things change, I had to change, and frankly, it was very annoying. And so this was kind of the start of me getting into Python, Dynamo, Grasshopper to find more efficient ways to do these types of things. So we're first going to look at just kind of our current workflows. We're going to get started on what most structural engineers work on from a day-to-day. Typical process involves starting in BIM. Usually that's Revit, can be other things. And from here, we're going to go into some type of plugin. Now, this plugin that we use, it could be many. It doesn't translate everything, but it translates some things, which is somewhat helpful. From there, we're going to go to analysis. And once we get into our analysis, again, this is 90% of projects that people do. We have a few different tools out there, but it works. I mean, this is how most people do, and they proceed. The question is, where do we go from here? You know, how do we get back to the beginning? How do we think about information once things change? Because the only thing that's constant is change in our industry. So some of the challenges, it's one way. You know, it's a one-way push. There's not a whole lot of options out there. Not every plugin is the best. They're not equal. And I think one of the biggest parts on this is, you know, how do we track changes? How do we know what's been changed, when it's been changed, and how do we change it? About back in 2016, there was a great tool that I'm a big proponent of called Dynamo, and that was released. So then we started going to this what we called an upgraded process. So we learn Dynamo and then we use a plugin. And there's many plugins out there to do this, but we just get most things. We don't get everything, we get most things. And we get into analysis. So we're excited, we're jumping in our analysis, we're do everything we need to do. The problem is we need a second plugin. And once we get in our analysis model, we have the same problem. So we have our second plugin, and then from there, where do we go? We're back in Revit, and then it's the same problem. And I think that this is a big frustration for many people in the industry, because while we've upgraded ourselves and using more visual programming tools, we have the same problem. So the challenges don't look much different. I mean, it's a one-way push. There are limited options available. Again, not everything is created equally in terms of plugins. It is a manual process. I would say that it may be harder of a manual process because most importantly, we started in Dynamo and now we're going to end in something else. And now we need to get that information back into Dynamo. And how do you do that? It can become very convoluted. Some of the challenges when we think about going from BIM to analysis, they're just some of the questions that people ask, you know, how do we track things? How do we handle separate analysis models? How do we handle offsets? I mean, all of these questions come up and there's not a lot of good answers out there, but this is just some of the challenges we all face on a day-to-day. So this leads us to the world of plugins. You know, there's a lot of them out there, and I'm not going to touch on all of them, but in the handout, I'll actually have kind of a breakdown of all of these just a little bit further along. Now, when I started in the industry, I learned RAM. RAM's a great tool. It's solid. And I used ISM, which came out maybe 10 years ago or so. And from there, I sent that into Revit. So I thought I was good. I was done. Check. Moved on. Well, over time, there's a lot more tools out there. There's RAM. I got introduced to SAP and ETABS. There's tools like Robot, which we're going to talk a lot about today, which has got some great workflows using BOM. And then there's other ones. There's TSD, GSAs, Trans7. This is not a comprehensive list. There are many more structural analysis softwares out there. I mean, there's probably 50. So I just picked 8 or 10 or so today. And we're not talking about all of them today. Now, when we look at plugins, though, we have ISM, which we mentioned earlier. It's mainly with Bentley products. There's a tool called Geometry Gym. This is a great tool, and have more about this one in the handout. It's a powerful plugin that works with Grasshopper, can get to a lot of different, from analysis to Grasshopper and so forth, a few more things. Constru is a really great tool, came out in 2016 or 17, I believe, and it's a plugin, and it has one of the best interfaces. It has a web interface that I've seen of any plugin. I mean, there's more, and then Excel is kind of a plugin if you consider it. CSI Revit is used on a lot of CSI products. You got Simplex, you got Rhino Inside, Tekla LiveLink. These are some of the plugins. And again, there are more plugins, but here are some. Now, on the far right, we're looking at all the BIM platforms out there and others. And so we have things like Revit, we have things like Tekla, we have things like Dynamo, we got Rhino Grasshopper, which are really, really used a lot in our industry, as well as IFC. Okay, so here are all the tools out there. Now, how do we get from one to the other? And as you add on these layers, it just gets more and more complex. And it gets probably very frustrating for a lot of users. I know it's frustrating for me. It's kind of like, where does this end? And so as of today, this is pretty up to date. So if you're curious how the whole web comes together, this is how it looks. This leads us to BOM. And I think that this is a tool that could help a lot of structural engineers tackle some of those pieces that we just looked at. So what does it stand for? It stands for Building and Habitats Object Model. It is an open source environment, so it's free to use, it's free to collaborate, and it works on multiple software platforms above just analysis. It was developed by Buro Happold in 2016 and released as open source project in 2018. It's data translations from many different software packages, which is really powerful. It is hosted on GitHub, so if you want to learn more, it's got all sorts of samples and things out there. It is updated sometimes daily. You'll just see every 5 or 12 hours are people pushing new updates to it. It is built on C# if you're curious, and you can actually go read the source code, learn a lot, understand how it was built. And the concept of it is more design, less code. I mean, the whole goal in this is that engineers spend time designing, analyzing, not spend all of their time with these plugins and getting lost and doing things manually. And its ultimate goal is to break down all these barriers between all these platforms to create one single source of truth. So the process with BOM is a little bit more unique, a little bit more streamlined in my opinion. So we'll start in BIM, whether say Revit or several other BIM platforms. And now we can use BOM. And what's really great about BOM is we can start grabbing all of these things. So all of these elements that we had and we were trying to assign, we can then grab them and then send them to analysis. Now I do put an asterisk on two-way. There are some structural analysis software tools that can kind of go back and forth. Not all of them can do that. So definitely check out GitHub to see in the wikis out there on which ones go two-way and which ones don't. I would say over time, you're going to see more and more have a true two-way on everything, which will take some time. Now, what's interesting is when we look at BOM back in this kind of web of software tools, it can connect to all of these. So there was, if you noticed on that previous slide, there was nothing that could connect to all of them. BOM actually can, which is really powerful. So how do you get it? It's pretty simple. You go to bom.xyz, it's the website, and here's the website, and you just basically click the installer. Once it installs, it's pretty seamless. It's just a easy install. It will automatically install in Grasshopper. So you'll get a BHoM tab automatically in Grasshopper. It will then install in Dynamo. And so it shows up on the kind of bottom left there in the add-ons. It also installs in Excel, which is really cool. There's a BHoM tab that automatically shows up and you can start connecting to BHoM. And then in Visual Studio. So let's say you want to import these libraries and you want to grab it off GitHub and take a look at it. You can start importing that information and then using the whole BHoM setup within Visual Studio. So how BHoM kind of works, it has these notion of adapters. And the best way I can describe it is BHoM is not like a standalone software that stands somewhere else and then you just open it and close it. It sits within existing software. So it sits within Dynamo. It sits within Grasshopper. It sits within Excel, and it also sits within Visual Studio. So that's just one thing to keep in mind. And all the examples we're using one of these tools. So just a little bit breaking down the BHoM toolbar. We're in Grasshopper right now. It's the same between all the way across. First, we're going to look at the adapter panel. So this adapter panel allows you to do a few different things. You're going to use it to connect to other software. So it's kind of the starting point on where to go. You're going to push data, you're going to pull data, and we'll get to some specific examples on how to do that. You can also execute commands, so you can actually then run analysis, which is really powerful from the adapter components. The next part is the engine. So this is the middle one here. And this engine panel, it allows you to modify something. So we actually have an example. We need to flip a bar orientation. So we'll show that in a little while. You can also get or set properties. So if you need to get a beam section, set a beam section. And the last one we're going to discuss is OM, and that actually stands for object model. I would say this is the one that you're going to use the most just on a day-to-day. And you can actually create BHoM objects from here. So that's one of the things. You might create a bar, you create a panel, create a load. You can also create BHoM libraries. So we're going to have an example of that, grabbing the W section libraries, wide flange sections. So here's kind of how it looks in Dynamo. Once you have Dynamo running, you can then go to the BHoM on the bottom left. And then you can, in this case, we're going to grab an adapter. So we're going to go to adapter. We're going to create an adapter. All right, great, it dropped. Well, we want to go to something. So we right click. You're going to right click a lot when you use BHoM. So you right click and then you go up to Revit. And then we're going to go to the Revit adapter. So now we have this Revit adapter in. Now, great. Well, we still need one more thing. We need a Boolean toggle. So this toggle is basically a true false toggle. And when we set it to true and we run the script, then it'll turn that adapter on. Until that thing's on true, it won't do anything. And I would say, just a side note, when you're in Dynamo, I would run in manual. I would not run automatic, especially with running with BHoM, or really anytime you use Dynamo, you should be using manual. In Grasshopper, it's the same thing. So we've went to the same component, we dropped it, and we right click, and then we can go to select an item. And just notice there's lots of other software here. We just mentioned Revit, but and it's not just structural. And I do want to mention that with BHoM, there's electrical tools, there's environmental tools, there's mechanical tools. It's very vast. So we're obviously focusing on structural, but it's much more than structural. So speaking a little bit more in the weeds for structural engineers, getting into the analytical library, question is, what is a bar? And this is kind of funny to me if you're worked in any different software. If you're in Robot, it actually is a bar, great. If you're in SAP 2000 or ETABS, it's a frame. If you're in RAM, it's a beam or a column. But in BHoM, it's a bar. So it's kind of a nice breakdown on how to see all these different components and softwares and tools. It's just breaking down the simple to the simple. So on the bottom right here, we're kind of in the structural element. We wanted to create an object. You'll see there's a bar, then there's a node, then there's a panel, then there's a surface. So It's great because they broke down all these different software nomenclature. That's nothing more than that. It's the same thing between analysis software, and then broken it down into most basic form. So now we're going to use the BHoM. Here are kind of some examples of just what it can do. And the first one we're going to do is starting from Grasshopper and going to robot. So this first step, we're going to generate our geometry in Grasshopper. We're going to create BHoM bars. And then finally, we're going to create our analysis model. All right, so first step, we're going to start generating our geometry. So here we are. We have our Grasshopper script. This is nothing more than geometry. So we're not talking about analysis. We're not talking about anything. Just a side note, the dataset is actually going to include all of these examples. So you feel free to download them, mess with them, change them. And this script, again, is just geometry. So we got some lines and we're just changing the size of it in X, changing the size in Y, the number of segments of this little tower. And you can find all sorts of YouTube and other things out there on how to create these types of things. And again, the scripts are available too. So if you want to learn more about how to do it. The last kind of piece here, again, this is just geometry. We can also change the number of floors. So great, we have that set up, we're ready to go. We're going to move on to the next step. The next step here is creating BHoM bars. All right, so we're back in Grasshopper, and now we've kind of just broken down the geometry a little bit. We want to grab all the start and end nodes of all the beams and all the start and end nodes of all the columns. So if you double click and then do the create a panel in Grasshopper, you'll notice that it actually is in metric units, the way they sit down, which is set up actually, because keep in mind, BHoM is all in metric. So just something to remember. And there's some tools that when you open up the script, you can see how it's created like that. So the first step is we're actually going to create an object like we did before from the object model tab. We're going to right click and then select an item. Now we're going to go down again. You see lots and lots of things here. We'll go down to structure, and then we're going to go to elements, and then we're going to go over to bar. And there's a few different options here. We're going to click the first one, the top one, bar. So we have this component. Now it needs several different things. It needs a start node, it needs an end node, and it needs a section property. So thankfully we have our start and end nodes of all of our beams in this case. So we have that set up. And now we need a section property. So we're going to grab a library, and we're going to go back to BHoM. We're going to go to object model again. You'll be here a lot as you go. And we're going to create data. So this is basically going to grab us. We're going to find the library. We're going to right click it, select an item. We're going to go all the way down to section properties. You'll see there's different places of the world, and we're going to go down to wide flange, or W. So now this is the wide flange library. I believe this is AISC version 15. And so if you click the drop down, you have more steel sections that you could ever use or know or care about. We're going to go to more common size. But what's great is this brings in all of that information for the section property. So we're not having to maybe create that. We're not having to set it up. It's there. So from there, we're going to copy and paste it and do the same thing for the columns. So in terms of BHoM and creating this BHoM bar, that's what we have. We have that BHoM bar in Grasshopper ready to go, but we haven't sent it anywhere, and that's going to be the next step. So the last step here is creating an analysis model. So we've created this stuff in BHoM. Now we need to push it to robot. All right, so we have a blank robot analysis model open. There's nothing in here. It's just blank. So we're good there. Now we're going to jump into our Grasshopper script. And so we have our beams. Now we have our adapter. We showed that a little bit earlier, creating robot adapters. Now we need to push something. So we're going to use the adapter panel. And we'll go to push. This is a very important concept. It's something you're going to be using all the time. It's usually that last step. So we have our push component, and it needs an adapter, it needs objects, and it needs a Boolean toggle at the bottom. We have our adapter, we're good with that. Now we need objects, so we're going to separate them. We're going to do all the beams in one push, and we're going to do all the columns in another push. It's kind of recommended to do it like that. So the last thing, we're going to actually now copy that and do the same thing for the columns. And so we have that, we're good. And the last thing we need is the Boolean toggle. Now, if you, I guess, double click, it depends on which one you're in. We can go to Boolean toggle and we're going to bring that into the active. And again, with Grasshopper, it's always on. So I would recommend setting things to false until you're ready to do anything. All right, so we have everything set to false. First thing we're going to do is go to the robot adapter. We're going to double click that so it'll switch it over to true. So we're good. Now we're going to first send the beams in. Now the timing of this, it could be a few seconds, could be 15 seconds, 20 seconds. If it goes over a minute, you may have done something wrong. So just be on the lookout for it. So we pushed all those beams. This wasn't edited, by the way, so that was about 160 beams or so. This will be 160 columns. So once those go in, you'll see some type of notification within the push. You can also put a panel at the end of it to see kind of what it does. If you want to kind of learn maybe if there's an error at some point. So once it's there, we're going to go into robot. So we have all these bars. Now we're going to check that the section properties came across. We're going to turn on our render piece, and there we go. So we now have all of that information. We've sent it into robot, so we're good. All right, so great. We've now created this robot. We started with Grasshopper. We then used BHoM, and then lastly, we brought that into robot. Now, one note, actually, the loads portion, that is in the data set. So it's a little bit more involved. It's a little bit more complicated. It's not super complicated, but it's a little bit outside the scope. If you check out the data set, you'll see that kind of bonus content, if you will. All right, so before we go to the second example, I just, think about sometimes this stuff gets dizzying. And I remember somebody was walking by and they said, is like, you're messing with that spaghetti. And, it does look like spaghetti. But what's interesting about this stuff is if it helps me as an engineer reduce errors, if it helps me be more efficient with my time, if it helps me analyze more complex structures or get them more refined, then maybe it's worth it. So, it is kind of funny. It can sometimes look a little silly with it, but it's powerful. And I think it's using these type of visual programming, whether scripting or Grasshopper Dynamo, it's powerful. So our next example, we're now going to go from robot to Revit. So this is a little bit different. It's the same principles. And now we're going to use BHoM to create a Revit model from Dynamo. Our first step here is we're going to grab everything out of Dynamo. We're then going to use BHoM, but this time it's a little bit different because we're actually going to create physical beams and physical columns. So all this information we're pulling, it's just analytical. So remember, it's just a line, and then it has some section property assigned to it. Well, we need to make a physical element if we want to send that to Revit in this case. And lastly, we're going to use Revit and actually push those physical beams and physical columns. So we're actually going to, again, grab that information. We're going to assign it a Revit family and then push it a native one in this case. All right, so this first step here, we're going to be in Dynamo and we're going to pull all those analytical beams and analytical columns. As always, we have our robot adapter, or excuse me, not as always, but we always, usually you're starting with some type of adapter. And if you can't remember how to go to adapter, it's in BHoM and then create adapter. And then if you, again, it's a right click, just always, once you get a BHoM node on the canvas, just right click, find it what you need. So that's just how you find it. If you can't remember again, the difference here is we're actually going to grab an existing model. So again, we have a analysis model. It's already been created. And now we want to read some information from that. So we're going to use the file path Dynamo node. It's a native Dynamo node. So we browse to our analysis model. In this case, we took that same model that we used earlier. We just switched it all to concrete, just FYI. You'll see that here in a little bit, just to give you a kind of a different flavor, a different example. All right, so we have our robot adapter. We're set at false at the moment, but now we're going to go create a pole. So we're going to be in the adapter. We're going to grab pull. So this is where it gets a little interesting because now we want to pull all this information. We have a model. Now we want to pull it. So it needs an adapter, which is what we have. The next part is a request. So this may be a little more advanced topic, but it's something that's really important to understand when you're working in BHoM. It's this notion of request. So with an adapter, we're going to create a request where it drops on the canvas, and now we're going to right click. There's a lot of different pieces within the adapters, but it's really powerful. Once we right click, we're going to go down to data, requests, and then we're actually going to go to filter requests. In this case, we're going to filter by BHoM type. So if you can think about it, we're creating kind of a request, and the request is going to be filtered by something, and that filter needs a type. So it's kind of maybe one way to think of it is I want a bucket of something. Now define what that bucket is. So we're going to create, in this case, we want all the bars. So we're going to go to the object model, and then we're going to create a type, drop that on the canvas. And now we're going to right click here and go over to select item. And just something to note, there's a lot of pieces here you're going to see. We're going to go to the object model, and then we're going to go to structure, then elements, and then now we have bar. So that's the type that of the BHoM, that's the type of bar. So we want a bar type, then we want to create a filter, and that creates our request. So we have that set up, we're good. The last piece here is we want to set that Boolean toggle to, right now it's set to true. We haven't clicked run yet, so nothing's happened. So we're going to set the model to true on the adapter side. We set it true on the pull side, and now we click run. So again, just something to keep in mind, I had an analysis model open here, so it generated an error. Sometimes it's good to see those errors. Make sure if you're grabbing an existing model, I would just have robot closed. That's probably the best way to do it. So once we've run this, now we have 320 bars. Now we've created a pull element. We've grabbed all this information. We've told it what type of information we want, and now we have all of it. So this next part now is we're going to create, we've grabbed all the information from Dynamo. We're now going to use BHoM to create physical beams and physical columns. All right, so we're still back in here, and we have all these analytical bars. Now we want to kind of break it down a little bit. We want to see, in this case, we want to grab a get property. There's different ways to do this, but this is maybe a simple way to do it here is a quick way. If you want to know where the get property is, it's in the engine and then get property. So we have this get property. We want the section property name. And again, I'd mentioned I switched all these from steel to concrete. So we have two types. We have a 24 by 36 beam and a 24 by 24 column. Great, and I know that most structures have more than two types of pieces to it, but this is mainly for simplicity here. Now the next piece is we want to create a list of all the beams and all the columns. Thankfully, it's only one type. So if we're creating just a filter, again, if you've done anything with Dynamo, it's a filter by Boolean mask. It's kind of the foundation, if you will, of any type of Dynamo workflows. So what we're trying to do here is understand, is that analytical bar, is that name of that bar this beam, or is it that column? The next piece is now we want to grab the center line of it. So again, that's analytical bar. It has an underlying geometry. We want to understand what that is. So this is a BHoM node that helps us get that information. So we've got that. Now the next part here is kind of interesting. We're going to start getting into creating physical beams and physical columns. So the beam needs a location, it needs a name. We're going to grab the center line that we did. That'll be our location. And then the 24 by 36, this is an actual Revit family name. So this is a native element. Family was already created. So it's ready to be used. Now for the columns, we have that underlying geometry. Now we need to flip it. when we created this analytical model, we created from top to bottom. Revit doesn't like that. It needs columns from bottom to top. So we had to flip it. So that was a component that we used. And all these components will break down a little bit more in the handout if you're kind of confused where to find them. So now we have used that underlying analytical geometry. Now we've created physical beams and physical columns. So this kind of last step here is, we've got Dynamo, we've pulled all of that analytical information. We used BHoM to create physical beams and physical columns. And now we're going to push that information into Revit. All right, so we have those beams. Now, if you're wondering where to get this node, you can actually do Control-Shift-B and then start typing something that only searches for BHoM components. So it's a great kind of quick way to get there. The other way to get here, this is creating an object. Again, something we're going to be using all the time. So you're going to right-click it, select an item, and then you're going to go to physical. So we want to create something physical element, and then a beam. So that's, if you're curious how to get to that node, that's how we got there. So as before, we have a Revit adapter, and now we're going to use this push component. The push component gets, there's one more piece on it. It needs a Boolean, just like before. And then it also needs objects. So we have objects. And then this last the last part here with push type. This is kind of a advanced piece within BHoM, and I would say it's something you're just going to learn more and more as you go about. We're actually going to create an object model. It's called enumeration. You're going to right-click, select type, and you're going to go over to adapter and a push type. Basically, this is dealing with how you can round trip information. Are we sending everything? Are we updating something? Are we updating or creating it? If you can imagine, there's so many different combinations of that. So I'd encourage you to check out the wiki or the handout for more information on that. So when we're going to Revit, we're just going to do create only. So we're just creating it. We're dumping into it. Now, I would actually recommend sometimes kind of clearing it out, if you will. In this case, I've had a lot of errors, and this is anything that's probably on my end, frankly, but I'd already run the script once, so I want to kind of clear the cache, if you will. So I ran it once. I sent everything to false, just so we don't have any errors. When I was testing this, I actually had a case where things were double creating. So I was creating double every column and every beam, which is obviously not good. So we've set everything to false, we run it, and now we're going to set it to true. I did cut this a little bit. I would say it took like 30 seconds or a minute or so, but it was there. And cool part of it is when you click on it, it's grabbing those Revit elements. So here are the Revit elements that we created, and that was the family name that we wanted to tell it to. So those were created in Revit. Those were already created there. There are actually some more advanced workflows if you want to create Revit families using BHoM as well. All right, so we did it. We started in Dynamo. We went to BHoM, and we actually created our Revit model using that underlying analytical information. All right, just some quick tips here on using the BHoM. Again, check your units. I've made several mistakes thinking everything's just, in what I use in the US. They are in imperial units. I would recommend using the localization notes. So there's a way you can actually convert things. So if you want to go to 2 meters or from meters or 2 feet, there's lots of information out there for it. I would always have the analytical software open before you run it. I know I made that comment on the browse if you got an existing model, so it kind of just depends where you're going. Sometimes I will say if you want to send something to it, you have multiple versions of some analysis software, I would open up the version you want to send it to. Sometimes it might grab a different one. Now in Grasshopper, you can actually just click and drag on any input or output on a node of a BHoM node, and it'll actually give you a hint, which is amazing. So click, drag, and it'll give you a hint on what it might be. Dynamo or Grasshopper, you actually do Control-Shift-B, and that'll search BHoM components. You can right-click any node and select help, and definitely go to the GitHub, go to the wiki, go to samples. There's plenty of options out there. Now, this last portion we're going to talk about is just getting started with lifecycle analysis, or LCA, using BHoM. Now, this is not going to be comprehensive. Kaylee Howd actually did a whole talk on Autodesk University back in 2020 on this subject. So I'd encourage you to watch her talk for a little bit more information on getting started with this. All right, so lifecycle analysis. What it does is it determines the embodied carbon in a structure. So it's something that's becoming more prevalent today, something that's more important, something that we're trying to do a better job of in the industry. It uses quantities, so it might be mass or volume, to determine what's known as a GWP, or global warming potential. It does require an environmental product declaration, also known as an EPD. So I'm going to throw a few acronyms out here, so bear with me. In the end, we get a global warming potential, and that's known as a GWP, and it has units kilogram CO2 equivalent. This is the equation. It's basically grabs a quantity. In this case, we're going to use volume. We multiply it by an EPD, and that's our global warming potential over a volume to get a global warming potential. There are many different data sets. So the key on this is, how do you get your EPDs? Where do you get them? How do you get to set it up? They will be mass or volume. So just be aware, be mindful when you're getting this set up. Within BHoM, you can actually create your own EPD. Let's say the data sets out there, maybe you don't like. They're updated periodically. And here are just some of them. There are many more data sets. There's some from other parts of the world. Some of the ones we're going to talk about today are mainly EC3, but there's quartz, there's ice, and there's, again, many more. This is not a comprehensive list. All right, so we're going to do kind of a quick example to help you get started with lifecycle analysis. So we're going to start in Revit. We're going to have all those physical elements that we created on our trusty tower structure here. We're going to use Dynamo. We're going to pull all those physical beams and physical columns. And lastly, we're going to use BHoM to apply the EPD to those elements. So we're going to see kind of what is the global warming potential of each of those elements. And finally, we'll evaluate it too. All right, so we're in Dynamo. And we have our, we're set to manual right now. I would recommend, again, running in manual. And so now we have our pull element. So we have a Revit model open, and we need a request. And in this case, we're using the filter model elements. This is basically grabbing everything that has a geometrical representation in the Revit model. So just something to keep in mind. In the handout, I'll show you kind of where to find that piece. And again, it needs a Boolean toggle. So when we set that to true and we click run, then it'll grab all this information. So in this case, we have all these Revit model elements, and we need to filter by something. But in order to filter, we need to know its family name. So we're grabbing every single element, every single thing with physical properties, and we're saying, what is your family name? From there, we're going to start filtering it to columns and beams. And this starts getting into the same game that we've done before with filter by Boolean masked. So we're grabbing every single physical element in Revit, we're filtering it, and now we're going to just basically say, all right, give me one list of all the beams and one list of all the columns. So this is really no different than what we were doing before. It's just now kind of going the opposite way of now mining the Revit information and then giving us that information back. So we have one list of all the columns and then one list of all the beams. All right, so this next step here is we have that Revit information. We already did that, grabbing all the physical beams and columns Dynamo. And now last, we're going to do this last piece here. We're going to apply the EPD to the elements and evaluate the global warming potential. Apologies here. I skipped a little ahead of myself. Before we do that, we actually need to assign the EPDs. Right, so we have we have all of our columns, and we have all of our beams. This next step is we're going to assign an EPD to those columns. So we have a list of all the columns, we have a list of all the beams. Now, we're going to use a few different BOM components here, and we're not going to show every single piece here. We're going to set the material property of all these BOM elements, and we're going to use the EPD within BOM. So in this case, we're going to use the EC3 data set. If you need to find it, you can do Control-Shift-B and type in EC3. And so there's steel, timber, there's different types of concrete with different strengths. We're using a pretty standard one. And once you have it, it actually has different amounts of fly ash or other materials that affect its EPD. So we're just kind of going to grab the top one here that's maybe more common mix design today. And we're going to grab that material. And then we're going to do the same thing for the beams as well. So for all the columns, all the beams, and now we're going to set the property of its property material, and we're going to set that EC3. So all we've done here is assign that information into its material property. So now, if you think of it this way, we've assigned that EPD to information that we've just defined to every single column and every single beam. All right, so we started with Revit. We went to Dynamo with all the physical beams, physical columns, and now we're going to do this last part and evaluate the global warming potential. All right, so we've set the property of all that information, and now we're going to combine that into one list. It's usually the best unless you want to do it separately, you can. There's many different ways to set this up. So these are mainly BOM components here, and now we want to evaluate that environmental product declaration. So it needs an element, it needs phases, it needs a field, and it also needs a Boolean. So we have all the elements. That's this list that we created at the top. We have the phases, and these are life cycle assessment phases. So we need 3 of them, and we need to create it in the list in order to run. And the last thing we need is a environmental product declaration field. So there's many different things you can evaluate here. We won't go into all of it. Again, we're just going to look at the global warming potential. So we need that field in order for this to run. So once we run, this is actually going to give us a list of what looks like nothing. And really what's happening is we're evaluating that BOM object. We're evaluating the environmental metric result. The problem is we need to break it down a little bit more. We need to understand, okay, that's something, but tell me what it is. Very, very important component of BOM here, the explode node. Think of it as, all right, just break it down. So we have this product declaration information, and now we want to know what's there. So once we said explode, you can send any BOM element to it, and it'll explode it. And this is giving us giving us every EPD of every single beam and column that we just defined. So based on what we've created, it has that EPD setup of every single beam and column. Now, if we just want to get a summation of all those things, this top, you use the math.sum, and then we have a summation of all the column EPDs, and on the bottom, all the beam EPDs. So, I mean, if you wanted to take this further, again, you can actually take all these EPDs, you can send to Excel, you can send it back into Revit. There's many, many different ways you can go about this. So what we did, we grabbed all those physical elements of Revit, we pulled that information using Dynamo, and then lastly in BOM, we applied the EPD, and then we evaluated the global warming potential. All right, so thank you all for your time today. If you liked this class, I actually hope that you did. Feel free to click recommend if you did. Drop a comment on the line. Definitely check out the data sets. There's a lot more information in there, handouts, and thank you for your time.